Good morning, ladies and gentlemen, and welcome to our production optimization seminar in the Caribbean. We want to thank you on behalf of our company for your presence and for your attention today. What we will do is we will do a very short presentation, and then the majority of the time will be invested in going directly to the application to show the benefits of our technology. Let me introduce first the team that will be working today and making the presentations. I will start by introducing Mr. Virgil Silly. Virgil is a geophysicist by training. He has ample experience in the oil and gas industry, and he is our business partner in Trinidad through the company Limitless Data Solutions. My name is Francisco Suarez. I am a petroleum engineer also by training and have more than 37 years of experience in the oil and gas industry on a global basis, but with emphasis in Latin America. What I would like to discuss the genesis of Datagration, of what our company is about, and then what is the value that we bring to the table. Datagration is the result of strategic planning of a group of leaders in the software industry that work in the oil and gas industry that wanted to provide to the market something totally different than what has been provided over the last decades. Something that is designed for oil and gas operators, taking into account the interests of oil and gas operators in terms of streamlining their internal processes in a way that they can maximize the value of the investment they have made in infrastructure and information technology to make decisions on a day-to-day basis, whether they are tactical or strategic in nature. So with that thought process, what they did was they acquired two leading organizations, one in Europe and one in the US, to create Datagration, funded the company and created the company with a robust team. Year and a half later, almost 2 years later, the company has evolved significantly, not only in the presence in the market, but also in the consolidation of our unified data model. We feel very proud of the unified data model that we have because we believe it is unique in the industry for several aspects. The first one is the model is totally agnostic. It can incorporate information and data from different databases and with any format of data. And virtually, we can connect to the unified data model information from production, from well planning, from geology, seismic information, financing information, accounting information, geographic information, you name it. So we have the opportunity to integrate all that information into one unified data model, clean the data, and also characterize that data for what we need, and then process that data using leading technologies that combine petroleum engineering disciplines, or what we call physical models, with artificial intelligence and with machine learning, in order to provide to the customers at the various levels of the organization with recommendations or summaries that provide the latitude for those users to make decisions with the best information available that combine the technical assessment with the economic assessment. So the decisions made by the users are impacted positively in the cash flows of the company at every level of the organization. And those recommendations are done in the visualization technology of choice of the customer. We're agnostic also in that aspect of our offering. I would like to briefly discuss the applications that we have in this model. We have currently 6 applications, and those applications are all oriented towards optimization of the main domain processes being done by oil and gas operators, whether they are production, artificial lift, enhanced oil recovery, completion, optimization of these processes is readily available and is already proven in the market for more than 12 years. We also have an application that we call ESG, Environmental, Social, and Governance, where we give the customers the opportunity not only to benchmark their performance from the environmental point of view in terms of emissions or water management or energy management, but more importantly, we measure actual data coming from the field as opposed to taking estimations. And finally, we have another application that we call development, acquisition, and divestiture that help our customers understand very thoroughly the value of the assets that they are going to either buy or sell in a very, very short period of time. Okay, what I will do is I will move on to the dashboards that we have. So what we will show today is a selection of dashboards that will provide the information needed for the customers to make daily decisions. I am going to briefly go from the process that we follow from the get-go, from the sources, and then discuss later the dashboards. But in summary, those dashboards have several characteristics. One of them is they are dynamic. They are not static. So a dynamic dashboard is fed on a daily basis by thousands and thousands of data points, even millions of data points that are processed with specific workflows in order to provide these recommendations. Very briefly, I am going to touch on what we do in order to do this optimization process. You see here in the screen, there are several data sources. In this particular case, 33 in this demo, there are several data sources that we can connect. We do not have so far a data source that we cannot connect to do calculations, whether they are accounting or technical or operational or financial. We can connect to the data source, providing, of course, using the information and protocols that we get from our customers to get access to those data sources. Once we are in the data sources, what we do is we characterize the data. In other words, we want to instruct the data source what is the information we want to retrieve from it. Like in this case, this is areas data source. We can qualify the information that we retrieve, that we just copy from the data source, but we do not change in the data source, and express we want production from these wells from this time to this time. And once we qualified or characterize that information, we copy that information into our unified data model with exactly the same parameters that are in the original data source. So once we do that, we use also the linkage of those data sources with the various entities. Basically, entity is a unit that can be measured and optimized. The most common entity that we use is well, but we can also use blocks or formations or locations or an entire field, or if you wish, an entire company as an entity. So once those entities are, once those entities are established, we have the signals that are basically is the data that can be retrieved on the frequency that we want, and also can be characterized in the way we want. So we have several elements here that can be used to further characterize the data. That data is clean, and when the cleaning process is finished, we have our own algorithms to clean the data. And if you want more details on this, I would like to invite you to see our webinars on our webpage associated specifically to the data model. But I would like to summarize in this opportunity that we have several workflows, hundreds of workflows specifically associated to resolve petrotechnical needs. We use also in those workflows to develop the specific application as we need in this module that we call build. We use in the prediction module, we use machine learning and decline curve analysis capabilities in order to complement our predictions. And I would like to share with you briefly also in the map application, we have the capability to look at the not only the different assets or the different entities like wells, but also the pipelines that are associated with our field, what the places are, basins, facilities, you name it. We can identify geographically any of the assets you want to track in your operations. So you could not only see the geographical reference of those assets, but also you can see the logistic considerations that you can determine whether you are going to discuss well intervention or any other requirement. So let's go to the dashboards. Once we have all that information, you will see here what is a typical data input of one of these dashboards. This is basically all the information required to calculate the economics of an oil and gas company. So we will not go in detail in that, but we will see what the end result is. So this screen that we see here is the result, as I mentioned before, of millions of data points being fed and being processed on a daily basis or on an hourly basis if needed. And here in one screen, you can see not only the production performance of the company, whether what the past performance was for oil, gas, and water, but also what is the forecasted production for those fluids based on the decline curve analysis that we have. We can also use not only our own decline curve analysis, but we can also use third-party decline curve analysis and easily integrate those into our platform. We are flexible and we are totally agnostic and transparent. We can not only have the analysis of the financial information of the company segregated by region or segregated by asset, and also the projections from the revenues and cost point of view and cash flows that we have or we will have available for investments or further considerations. We can have all this information in one screen, all the costs associated with our business. We can even, by a click of a button, we can even determine the same level of information for each specific field if we choose to do so. We could click here in each one of the fields that you have, and this automatically populates the information for that specific field. And if you want to do the same thing for a formation, we can do exactly the same thing. Now, if there is a need to go in detail for specific requirements, this, as you can see, are summary of wells. These are all the wells. In this case, we have 3,900 wells loaded into this demo. So we could identify the aggregate of those wells, or if we want to pick one specific well and determine what is the individual performance of that well, we can do so as well. So this is a very flexible tool that can go to from the big picture for the manager to the detail of a well for a petroleum engineer or production engineer that wants to follow specifically what is good or what is not good about that well. So those are examples of dashboards that are readily available and being used by customers. I would like to share with you also another dashboard that I believe is key for identifying what can be done in a company in the inventory of wells that a company has, either active or inactive wells. What can be done to optimize the economics of the company based on the selection of the wells to be intervened or to be reactivated based on a specific budget that a company has. In this particular dashboard, you see basically a summary of wells being ranked by what we call scores, underperformance scores or problem scores or reactivation scores, scores that rank wells based on their not only technical and operational merit, but also on the economic merit. So the ranking of wells, and Virgil will expand more on this while he presents. In this ranking of wells, we can determine where we suggest that the intervention needs to be done on which wells and why, and what is the economic impact of those wells. So this is a summary of what is being done from the technical perspective. You see here, we track the casing pressure, tubing pressure, of course, the volumes of production, the financial information. And you see here in this part of the screen, you see the scoring that we use. We use three different types of scoring systems. One is what we call the problem scoring, and the problem scoring, we typically include not only the technical, not only the mechanical problems of the well itself, but also the level of water, the water cut that the wells have, if there is gas influx or any other issues that could be affecting that well. So that's what we call the problem scoring. In the reservoir scoring, we qualify the characteristics of the reservoir in the drainage area of that well. We use the Voronoi polygons to determine that. And basically, we measure not only the static, but also the dynamic characteristics of the well to see what is the potential of the deliverability of that well in that specific section of the reservoir. Now, in the production score, we also analyze what has been the cumulative production of that well versus the reserves remaining on that well and the levels of production. So we combine those factors from the technical perspective, and we combine reservoir systems with well systems and with surface facility systems in order to analyze in an integrated fashion what are the best candidates to deliver the most potential from the production point of view, and then match that information with the economics, whether they are gas sales or oil sales or water management cost. We combine all that information in order to say, this is well number one to be reactivated, and these are the reasons, and this is why. So this is a very powerful tool for the production engineer or for the well intervention engineer to determine where he or she will need to put the money allocated to his budget in order to produce much better results. That information is readily available in the companies, in the oil and gas companies. The only thing that is different here is that we are processing that information that is already available and paid for. We are processing in order to uncover insights that otherwise would not be that apparent and allow engineers to make much better and informed decisions with the same sets of data. This is an example of different analysis that can be done for the performance identification and prediction of wells based on past information. We can do all sorts of analysis. This can be configured as well to the specific characteristics of your reservoir. So this is a very, very flexible and powerful tool that uses engineering, artificial intelligence, and machine learning to the benefit of the oil and gas professional. And I would like to invite my colleague Virgil to share with you a couple of other dashboards. In this case, the production summary dashboard that is also very, very powerful and very helpful for companies to track and follow and identify in their daily business what needs to be done in order to enhance production. Virgil, would you please lead us through this presentation?
Thank you, Francisco. So here we have the production summary dashboard. And this dashboard really kind of defines and can show you the history, the historic, the current, and also the forecasted production of of your facilities, of your wells, of your assets, of your field. And if we look initially at the first graph, which is at the top left, we can see that we can see the production of your gas, your water, or and your oil. And if we move across to your right, where we can see the vintage gas production, we can this gives an again a historical look at the performance of your assets. But what is nice about this, we can see is that when you have, for instance, you have infill drilling campaigns, you have workover exercises, and so on, and we can see how those over the years, we can see how those exercises can affect your overall production. One other thing we could look at, because wells are georeferenced, again, we will be able to view this data on a map. And so this can indicate to us, what facilities are in the area where we see we have where we want to improve our production. Do we have roads infrastructure, pipeline infrastructure? How easy it is to get into those particular areas, especially onshore Trinidad, where we have issues, where we have several hazards. And as Francisco showed earlier, we can also take this data now, and we can segment this data via field, via formation, via region, via asset, and so on. So it's really a dynamic dashboard, and this is really obtained by Petrovisor being connected to your production data source, whether it be an Excel data source or you have a production database. Another aspect that we could look at, we could delve into it more deeply, is to look at the cross plots. And Petrovisor comes with a host of workflows that we could utilize, and we can use these cross plots now to help predict future production performance, right? By looking at different KPIs and how they behave. So some of the metrics we can look at are, for instance, the best 90-day production or your estimated ultimate recovery. And we can also correlate this information with factors such as horizontal design parameters, and also drainage areas, right? So this is a key dashboard that can be used in that can be looked at every day to help in making key decisions. Another dashboard that we look at is also called the well status dashboard. And this well status dashboard is really key to really keying in on wells and their performance. Now, if we look at the top left, we could see which wells are in our area of interest. So these wells can be your active wells, your inactive wells, your wells that are shut in, wells that are allocated for maintenance, and so on. And this is just really the area of interest that we are looking at. If we move over to the far right of the screen, we see a table here which shows the wells which give positive cash flow and wells that give negative cash flow. So of course you're happy with your positive cash flow, wells that give you positive cash flow, but you want to know which wells give you negative cash flow and what can we do with it. So this table gives this, and how this is achieved is by, of course, Petrovisor again connecting to your production database as well as your accounting database. So we can pull that information and develop, and using Petrovisor's unique, very robust economic engine, we can pull out information like this. Now, if we go up to the break-even lifting cost, which is the graph, the histogram in the middle, we can now look at the ability to have which wells would break even depending on the cost of certain commodities. For instance, the cost of oil or the cost of gas at that particular time. Now, and what we see here is the bars show the amount of wells which would give you positive cash flow, and the wells and the number of wells that would do that. Now, the blue bars indicate the wells that are active, and the green bars indicate the wells that are inactive. And how this particular graph is helpful is that it can help in that making decisions of which wells are to shut in, which wells we should keep online, as the price of commodities change. And because of again the robust workflows in Petrovisor, we can also have a look at, if we look at the bottom two tables, we can also have a look at which wells are the best candidates for reactivations, which wells are the best candidates for workovers. And this is done by looking at different KPIs. And one particular KPI that is important is really the return on rate of return. And this again is achieved by Petrovisor's economic engine, being able to calculate these values. And what it also takes into consideration things such as the taxes in the country, the cost of services, the cost of operations, and so on. And this is definitely key in terms of which wells are the best wells to do workovers, to do reactivations, and schedule for maintenance. So now I'll just hand you back over to Francisco, just to wrap up.
Thank you. Thank you very much. At this stage, I would like to open the floor for questions and answers. The summary of our presentation is achieved by not only showing the value that we provide to the table by integrating data, but also the value that you can derive from the data you currently have being processed in near to real time, so you can make much better decisions with the data you have. So please, if you have a question, please send it to us and it will pop up in our system and we will be very glad to answer those questions. Any questions, please write it down. Okay, there is one question here. How well does your data governance and data quality needs to be to implement a solution like this? Thank you for the question. In reality, there is no perfect data in the oil and gas industry. Always there is a quality process and a screening and a cleansing process to be done. We have a very robust cleansing process, but the quality of the data that is good to make decisions based on the processes that we do is the quality of the data that the customer identifies as accurate. We do have cleansing algorithms that clean data, but we always go to the customer and discuss our results with their input in a way that we ensure that the data being used is accurate enough for processes. Any other question? There is another one. Can we implement production alerts that can indicate when a price of commodity drops? The answer is yes. We are connected not only to the technical and operational databases of the organization, but also we are connected to the financial and accounting data of the organization. So in the financial forecasting, organizations typically consider scenarios of commodity prices, and we can identify thresholds where whenever the commodity price goes one way or the other, alerts can be sent. So yes, it can be done. Looks like there's no more questions. So again, thank you very much for your participation in this webinar. We invite you to visit our webpage where we will have this webinar recorded and available for you to review. And if you have colleagues that did not have a chance to participate, I would encourage you to please invite those colleagues to also visit in our webpage. We will have there not only this webinar, but all the webinars that we have done. So we conclude with this, our session for today. Thank you very much and have a great day.